Good morning, friends. Today we are going to discuss about the ESQL clustering theoretical part. Okay, practical we are not going to show, but we are going to discuss about the ESQL clustering theoretically, how it works, what exactly ESQL clustering means, how it will help for the database team, and mainly how it will help for the business uh, and application functionalities. Okay, so before we proceeding that, let's discuss about the high availability, and then we can go for the ESQL clustering. Okay, wait a minute. Yeah, so before going for the SQL clustering, like uh, so here we have a one SQL server VM. Okay, we have a one SQL server VM, and in that we have a one instance. So previously we discussed about the like high availability rate, like a log shipping, mirroring, replication. These are database high availability. What is that means? What is that means? We are maintaining the one more copy to the other server instance. Okay, we are copying one more copy here. Log shipping, mirroring, and replication are database level high availability. So if something goes wrong for the database, we have one more copy maintaining on the other server so that we can connect the our users connect to the database. That means we are providing the database level high availability. Why? Because we have one more copy maintaining to the other server so that our data is synchronizing. If something goes wrong, one copy, another copy parallel synchronizing it. So for that, the users or application will connect, but that required some uh, extra effect to bring the database online. But those techniques are mainly for the database, not for the server. What is that means? Suppose here this particular computer uh, crashed. Okay, this particular computer is crashed. What will happen inside the what are the SQL we have? What are the SQL server we have? And what are the service we have? That will stop, right? So that this computer won't available. If computer is not available, then our SQL server won't connect. So for that, we have maintained the database to the other things. Here, client what needs to do? They have to change the application constructing irrespective of the SQL instance name. So that required some extra effect for the application and as well as the users and other areas where we configure the reports. Those are for only for database level. Yeah, database, 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 database. We are synchronizing. That may be log shipping or that may be here. These are the database level. So here what is happening? Only for configuring the database level, not for the server level. So to uh, get the server availability, the Microsoft introduced clustering, but that SQL Server clustering depends on for the Windows level clustering. Why? Because uh, initially what we discussed, like what is the SQL Server? SQL Server is software that is installed on the any virtual computer. So our software directly won't involve the clustering, because the clustering is the concept based on the Windows environment. For that in Windows environment, we have to install the SQL Server. So if you want to go for the high availability in the server level, then while installing the SQL Server, we need to choose another method. Like generally what we can do, we can install the SQL Server like a standard method, right? Somebody's being, yeah. So let me, yeah. So while installing the SQL Server, what can do, we can go for standalone, or else add the features to the SQL Server. But whereas if you want to set up the or install the SQL Server in the cluster, what we need to do, we have to choose another uh, area in the same SQL installation, but we have to choose install as a secure clustering. Why? Because if something goes wrong, this particular computer or this computer or node, what will happen? What are the resource? What are the server we have that automatically move to the another server? So that will provide the node availability. So let me go for the some exact theory of the clustering. So clustering is a Windows level high availability option to increase the availability of the physical server, hardware, operating system, and SQL Server instances. So here, what is that means? What is that means? Like if something goes wrong, this hardware, operating system, then we have one more computer to host the SQL Server instance and servers. So that means we are providing the high availability to the our hardware and as well as SQL Server instance. So clustering is nothing but a to joining the computers together. So clustering means like joining the joining the computers together uh, is called like a clustering. The clustering is nothing but a joining the uh, two or more nodes together in the one place. Okay, uh, that is called terminology clustering. But in the Postgres, clustering is different. That is like only for database level. So clustering means like it's kind of like a container collection of nodes together to join into the one application, that to Windows level. So here, uh, if you want to join the nodes or computer, we need Windows failover cluster manager. So the thing is like the clustering is the main based on the virtual computer or nodes. Why? Because they in the Windows level, the computers will join. So the terminology we can call Windows failover cluster manager. This feature available on the Windows servers, and building the Windows failover cluster. Windows team will build the Windows cluster. Once the Windows cluster is built, from there top of that our SQL server team install the SQL server. Okay. So that is, as I mentioned, that is not like a standard process. So we have to go for the select the different method. So here the thing is like, let me take one more EMS paint. Here, what are the resource we are going to use? Those are the shared resource, not like a common uh, independent or dependent resource. What are the resource we are using? Those are the shared resource. Why? Because if something node is crashed, then other node has to hand over to take the ownership. So the thing is like, here main our data where it is stored, the data will be stored in the physical disk, right? Like a virtual disk, right? So the our data will be stored into the normal disk. But coming to the uh, clustering, the disks are what are we are attaching, those are not a normal disk. Those are the cluster disk. So the cluster disk will provide from the storage team or Windows team. That will came from the SAN storage, but those will uh, come as a cluster. Okay. So these are the, oh, come on, think like a, this is a storage disk. In that storage disk, we are going to keep the our data file, MDF file, and binaries. Okay. So here, let me go for the before building the Windows cluster or SQL cluster, we need to understand the network concept. Okay. So here the main core components are Windows level and as well as the network level. So if Windows cluster and networking is communicating as expected, our SQL job is very easy. So for that, we need to understand the 2 points. One is the main point is the networking. So for that, we have a in that networking, we need to understand two network concepts: public network, private network. So while building the this cluster configurations, what they will do, Windows team generally, uh, normal computers, we have only one uh, network card. But if you want to participate the computers in the clustering, the Windows team, what they have to do, they have to attach the two network cards. Okay. One is public network. What is it? Let me go for my notes. Yes. So the for the what are the computers we are going to make a cluster. Okay. I want to make a these two nodes, these two computers, make a clustering. So for that Windows team, what they have to do, they have to attach the two network cards. They have to attach two network cards. Let me go for top. They will attach the two network cards. One is for public, another one is the private. So here what will happen? This public network used for the uh, this public network used for the communication between for the users. Okay, this public network used for the users. This public network used for the users to connect. Public network is the network where users are connected to and communicate to the cluster SQL Server instance. So what they will do, the people or users or application will connect to the this network. Once they connect to this network, using this network, uh, they will connect to the SQL Server. That is the purpose of the public network. For that, Windows team will attach the public network card to the our computers. And one more, private network. That private network, what it will do, it will use it for the communication between the clusters. So this private NIC cards especially used for the internal node communication, not for the external node user communication. So here public network and private network. The public network used for to connect the users, to connect the application, and to interact the our SQL Server instance. Private network is for the to communicate between the nodes. So these things will set up from the our Windows team or network team. This is the one key topic. Another one is the virtual name. So virtual name is the kind of a listener. So the listener we can discuss in the our always energy. So the thing is like virtual name is the very important here. So here the other one is virtual name. Virtual virtual name. So here virtual name is nothing but the client access point. So the virtual name is nothing but a client access point. We will discuss in another few minutes why exactly like we are giving the virtual name and how it will use to connect the our SQL server. So virtual name is a nothing but a DNS name. That DNS name will map the IP address. So using the virtual name and IP address, the users or application will connect. So here, uh, let me explain other things. Virtual name, right? Virtual name, uh, virtual name is the client access point that is used for users or application to connect. And that virtual name, we need to map the IP address. Those IP address from the this network range. So the IP address will provide from the our network team. So this virtual name IP address we need to provide while installing the SQL server. So using this virtual name and IP address, users will connect. This virtual name is kind of like a shared resource. So other thing is like a shared disk. Shared disk means like here generally what we will do, this is a SQL server. So SQL server, previously what we used to do, we install the SQL server to the normal disk. Those disks are physical disk. Physical disk means like the disk won't move to the other computer. The disk won't move to the other resource. That is our kind of like a physical. That will dedicated for or will stay on the one computer. Coming to the uh, cluster disk, what will happen? These disks will move, maybe this computer or maybe this computer, based upon the active nodes. Why? Because these disks are cluster disk. So this disk will create as a cluster disk and they will attach to the our computer. So what will happen while installing the SQL server? It will show the disk what are the available or what are the attached to the that particular cluster. Okay, this particular sandbox or cluster, what are the disk we have, that will visible. While installing the SQL server, what we need to do, we need to keep our data files. We need to keep our data files or one disk. We need to keep log files one disk, and we can keep MDF or system database to the another disk. Okay. So the thing is like, so if you do like that, what will happen? These are the our storage cluster storage disk. Suppose this computer, this computer got crashed. What will happen? This will move to the, let me, this is a before that, let me open the our software media. Let me see. I can see something. SQL software. Web as administrator. Yeah. So while installing the SQL server, what we can do, we can install the SQL server in the one computer. So what is here? Our Windows team will build the Windows cluster. Okay. Our Windows team will build the Windows cluster. Our Windows team will build the Windows cluster. Windows cluster. Once they build the Windows cluster, they will hand over to the our DB team. So for that, uh, before installing the DB team, like we will request the some cluster disk. One is for a data file, another one is a log file, another one is for the tempdb and other files. And apart from that, we will ask virtual name and virtual IP address to client access point. Okay. So we need what we need mainly from the network side. We need virtual name and IP address and as well as the disk. Once the Windows team hand over to the DBA team, what we can do, DBA team will log into the any one of the computer, any one of the virtual node. Then what we can do, we can start the installation from the this blade, not from the here. So generally, whenever we open the SQL Server installation, what we have to do, we will go for the standalone. But the thing is like what we need to do, we need to here two things: new SQL Server failover cluster installation and add node. So first go for new SQL Server failover cluster installation. Those things we need to start begin from any one of the one virtual computer or node. So while installing the SQL Server, we have to choose the cluster disk, and uh, then we have to provide the virtual name, virtual IP address, and complete the SQL Server installation. So in the one computer, go for the this installation blade. So other computer, what we need to do, log into the other computer, then go to the software. That time we have to choose this one, add node to the SQL Server failover cluster. So here we need to choose this blade. Why? Because we already installed the SQL Server here. For that, we are maintaining as a high availability. For that, we need to keep the binaries. For that, uh, go for only add node. But that time, it won't ask any cluster disk. It won't ask any virtual name. Simply, it will ask to add node the computer. So while choosing that option, it will ask which instance this we have one instance, right? That will ask for to add the add node. That's it. The thing is like now what will happen? Uh, this is the our SQL server and running on the one computer. For that, disks are storage. So if something goes wrong, if something goes wrong, this particular computer, what will happen? This disks will this disk will move to the here. This will disks will move to the here. Then what about the SQL server? The SQL server, we have given the virtual name, right? That virtual name, the virtual name, it will come to here. This virtual name come to the here. Then it will point to the this because whenever the SQL server like computer down or fail over the this SQL server, what will happen? What are the resource are allocated to that particular server? It will take to the another computer. Okay, so here we are providing the server level high availability. That means like what are the database we have? What are the database we have? The database are we are keeping into the we are keeping into the storage, right? So the data also will move to the another computer. Why? Because this computer down or this SQL server is fail over to the another server. And what about the our customer connectivity? Why? Because generally what we will do whenever we connecting to the SQL server, what we need to do? We need to connect the SQL server instance name, right? Suppose if it is failover to here, that time what we need to do? In the application side, we have to change the SQL Server instance name, and the same thing, the users or application will have to point to that particular instance. So for that, avoiding that, what we are doing, we are going to use the virtual name, client access point. So using the client access point, no need to worry about where this disks are running, and uh, SQL Server is running. So what will happen? This using the virtual name, this virtual name always pointing to the active node. Active node means like here, uh, while installing the SQL Server, what will happen? The SQL Server service will install, right? SQL Server services will install, and it will running here. So at the time of while adding the computer using this option, add node. So what will happen? What will happen? The SQL Server service will install. SQL Server service will install, but this will be stopped. This will be this will be this will be stopped. Let me go for here. Services running. These services stopped. So here the active node, like what are the you install the SQL Server first time, right? That time the services that particular computer, whenever we install the SQL Server, what will have? We have a database engine and as well as the SQL Server agent, right? Those service will install and those will be running here. But other computer, what we did, we add this particular instance to here. So here the binaries will install and services will stop. So at the time of failure, what will happen? So if this computer is crashed, so what will happen? This SQL Server will fail over to the come on. This SQL Server fail over to this particular computer. At that moment, what will happen? These services will come as a running state. These services will come as a running state, and our SQL Server will be up here. So that time means like what that means? The SQL service at a time running on the one computer. Other computer will be stopped. So while connecting the users from the public network using virtual name, the virtual name will pointing to the active node. Active node means where the services are running. Then the client will connect to the SQL Server and it will get the data. Suppose if it is failover, what will happen? Uh, the client will connect to the active node. Why? Because this is stopped, this is running. This client access point will divert it to the another computer. From there, SQL Server will access. Why? Because all our resource will running on this computer. So that is the reason we are using the virtual name while installing the SQL Server. So virtual names and IP address. So what it will do while giving the virtual name IP address, in the background, in the AD computer level, there is a one computer object will create. Okay. So using that computer object, the SQL server will connect. So this practically I will show in the always and easy. So here the thing is like I don't have the public network cards, private network cards, and storage things. So that is the reason I'm not going to show the practically. But once we discussing the always and easy points, you can understand the SQL clustering, and SQL clustering nowadays no one using. But few of the organizations, what are the people are install the clustering, they are using the SQL clustering and we are maintaining. But what are the new customers are coming, they are moving to the always energy future. Okay, but what are the legacy customers and the legacy applications they install in the past? No, they don't want to move to the or migrate to the other computers and other things. So that is the reason still companies are using the SQL clustering. Okay, so that is the reason we need to understand the this terminology. So what is the public network? What is the private network? And what is the virtual name? And what is the cluster disk? Okay, then how the failover will work? Okay, uh, so here what we are, where we are. So the users are client or application, no need to bother about the uh, uh, SQL service running. It's always pointing to the active node. In the active node, the SQL server will point. If it fail over, then what will happen? Uh, the client access point will connect to the our other SQL server. Why? Because our shared resources are moved to here and binaries are already installed here, so that SQL service coming online and SQL server stopped here. And the application is pointing to the virtual name instead of the computer. So here the thing is like we have one more uh, concept called quorum. Okay, the quorum is the very important. The terminology I'm explaining. Okay, what is the public network? What is the use of the public network and the private network, and what is the virtual name? What is the use of that? Okay, so in installation, I will give the one document. While going through the document, you can understand this terminology and cluster disk. But by looking at this diagrams and theoretically, you will get some confusion. But if once I give you the document from the Microsoft, you can most of the doubts will be clarified. So here virtual name. Then other key points is the quorum. Quorum. Other key point is a quorum. So the quorum is the important for the clustering. Okay. This quorum also will configure from the Windows team. Okay. This quorum also will configure from the Windows, and while installing the SQL server, we have a different kind of quorums. That thing we need to select node majority or file share or some other things. Okay. So we have to choose the quorum while installing. So here, so let me go my document. Yeah. So the quorum is the main role play for the SQL clustering. So how it will play? So the thing is like when we go for the our database, generally database what we have data file and a log file, right? So like that, the similarly we don't have data file log file, but The log file, the mainly used for the current transaction. It will store the what are the active transaction happening, right? So like that, the quorum similar to transaction log file, it will apply the all the changes. It will apply the all the changes. What does that means? So what are the nodes participating in the cluster? It will record the all the changes what which is happening in the clustering. So the quorum is nothing but a one log file similar to the transaction log file, and it will records what are the changes happening on the clustering. If something goes wrong in the active node, any changes made on the active node, then pass. Yeah. So here, you know, pass node. Yeah. So here the quorum, as I mentioned, it's a main component. Right? It has a log file. It is a log file. This log file will be stored in the quorum disk. This quorum disk, what will have? It will have the all the our active node information. Okay, active node information. Suppose our SQL server is fail out to the another computer. Okay, then what will happen? What are the changes are happened in the active node? Then, but we fail out to the another computer, right? Those modification will apply to the this quorum log, so that based on the then what will happen based on the this quorum log file, our this computer will take the ownership of the this resource. See, whenever failure happen, how the disks are taking the ownership, the using the quorum log file. This quorum log file, it will record the all the active node information. If it is failure to the another node, what it will happen? What are the changes we have? Those information, it will give it to the another node. Once we give in the another node, what are the resources we have? Those resources will take the owner. So here, initially, the disks are VM1, VM2. Okay. So suppose the SQLs are running up and running here, the disks are here. So the owner of the disk are computer one. Suppose this SQL server is failover or this VM is crashed. If VM is crashed means our SQL server automatically failover to the another computer. So once it's failover, the disk also how to failover it. Once it's failover, this disk ownership which will take from the uh, VM2 based upon the quorum, because this quorum will have the log file and it will maintain the cluster information like which one is the active, which one is the passive. So suppose if the quorum is not there, if the quorum is not there, what will happen? Suppose if the quorum log file is not there, what will happen to the our clustering? Let me take one example. MS Paint. This is the one computer. This is the another computer. Just I'm taking example. Okay, this is the one computer. This is the one computer. Okay. So this all four computers join in the one Windows cluster. It's all four computers join in the one Windows cluster. One Windows cluster. What we did, we install the SQL server from one computer. Let me go for VM1, VM2, VM, VM4. So this all four computers uh, we, joined together in the Windows cluster. So here one VM we install the SQL server from the here like a new SQL server for the cluster. Then what we did, this computer we did only add node. Add node I will show in the bottom. Okay, add node. I did in the main installation happened in the one computer, but other computers what I did, I add the add node. Why? Because I want to like this four computers are participating in the Windows cluster. I install the one cluster, one SQL server in the one VM, and remaining computers I did like a add node. If you want, you can go for two nodes. But here, what I'm thinking, this computer also goes wrong. I can go use for another VM. Suppose if both also gone, I can use for another VMs. So that is the reason what I did. Uh, like management, one computer, one SQL server install the one computer. Remaining computers, we did like a, just add the SQL cluster. So another computer, VM2, it is having main installation. Okay. Here main installation we did. Here what I did, I added the here I added to the VM to the here. Okay. So let me go for the confusion now. So here VM like a minus this is VM a minus VM a minus. Now this is the VM B minus. This is the I call like a B. This call like a. So here VM B minus. Here VM B minus. So here main installation remaining, yeah, add node, add node. Main installation, add node, add node, add node. The same thing for the same thing for here This is called same thing for here. Let me go for. So here, and I will go for C, go for D. Then we will go for VM C minus VM D minus VM C minus VM D minus this one B, this one D. VM D minus this one VM C minus. So here I have a four computers. All these four computers joined together in the one Windows cluster. We have one Windows cluster name. So here this Windows cluster name and as well as IP we required. These things will taken care from the Windows team. Once they did, we install the SQL server here and computer 2, computer 3 and computer 4. But rest of the nodes we just as a add node to keep the binaries. So here what will happen? The quorum. Just we are discussing about the quorum things. Okay. So this A having this A, this A having some storage disk. This A, B, this having some storage disk because we need to install, we need to keep the some like data, right? So each everyone having shared disk. This one having shared disk. So all this what I meant to say, all these four computers communicating through the private network. All these four computers communicating through the private networks. All these computers through the private private network. Okay. So now the computer and the VM1, we have a SQL server A that is having dedicated SQL storage disk, and in the computer 2 we have a dedicated instance SQLB that is having uh, shared disk, and computer 3 dedicated instance and it has dedicated storage here, and computer 4 instance D, the disks are here. So as I mentioned just before, the disk will available in the active node. Active node means where we have the SQL server running. Suppose here now we are discussing the quorum, right, main component. So the here uh, the computers are uh, communicating between the private network. Suppose what was happen, uh, Here VM1 and VM2. Okay. Lost the communication between VM3 and VM4. What does that means? VM1 is not able to communicate VM3 and the VM1 is not able to communicate VM4. The same thing, VM2 is not able to communicate VM3 and VM4. So vice versa, VM3 not able to communicate VM1 and not able to communicate VM2. VM4 also not able to communicate VM1 and not able to communicate VM2. So in this scenario, what will happen in the cluster? What they will think, these computers are down. These computers are down. What it will do? We have we kept the our SQL server binaries, right? So here VM1 we have a SQL instance, and the same thing what we did, we just add the binaries here, right, in the VM3, and as well as VM4 we add the binaries, right, just add. So in this scenario, what will happen? Our SQL server is up and running here, but we lost the communication. What will happen? This computer, it will try to bring the resource online. Computer home. This computer will try to bring the resource online, and as well as this computer, it will try to bring the resource online. This computer, this computer will bring the resource online. So what will happen? That will have some configurations issue, and that disk will corrupt, right? This disk will corrupt. Why? Because it lost the communication from the another node. Then what will happen? We kept the binaries to the other node as a passive node in the previously. That what they will think, this computer has done. Then immediately what other node it will think, it will try to bring the resource online. At the same time, other computer also, it will try to bring the resource online. Then we have a data corruption. The same thing, other what you might say, other servers also do the same thing. This what you meant? Yeah, yes. Uh, this computer where we have VM2, right? This is binary. See, this also it will try to take the ownership. So one computer, like one SQL server, the other SQL server try to take the resource online. So then we have a data corruption, and the disks will corrupted. Then entire environment will crash. So for that, what it will do? A quorum will maintain the uh, voting mechanism. Using the voting mechanism, and what one? Quorum is designed to handle the scenarios. The cluster will force the cluster service stop in one of the nodes to ensure only one of the resource group. So let me go for the theoretical. We have a 4 nodes and one instance of SQL server running on each node. So we have a 4 nodes and each computer one SQL server is running. Node 1 and node 2 lost the communication with node 3 and node 4. In this scenario, node 1 and node 2 bring the SQL Server instance resource owned by node 3 and node 4. So node 1, node 2, what they will do? They will try to bring the resource online for from the node 3 and node 4. In the second way, node 3 and 4 will try to bring the SQL Server resource owned by node 1 and 2, which will lead to the disk corruption and other issues. So here the quorum is designed to handle these scenarios. The cluster will force the cluster service to stop in the one of the nodes. So here what will happen? The cluster will services will stop the one services. So here for the cluster service stop one of the nodes to ensure the only one of the So here this quorum is designed to handle this scenario. The the cluster will force the cluster service to stop. So whenever we building the Windows cluster, what will happen? Each computer, one cluster service will be installed. Whenever we building the cluster, in the background, in the service at MSC, in the server manager, one service will install. That is cluster service. That is cluster service belongs to the Windows cluster. So we have a cluster service. Cluster service. Cluster service. Also cluster service. Cluster service. So here this cluster service belongs to the Windows clusters. So that is the reason each computer we can see the one cluster service. Okay. This cluster service install in the initial when we join the computers in the Windows cluster. That is the reason each computer having one cluster service. So here what will happen? This cluster service forcefully stop the one of the nodes to ensure only one owner for the particular SQL Server resource group. So that means this is the all the resource, right? This resource has to allocate the only one SQL Server, not for the other SQL Server. So why? Because we lost the communication and other computer, what they will think, the other services stopped. I need to bring the cluster service online here. Why? Because main service installed here, other computers, the SQL servers installed, but they are stopped. Okay. So if you lost the communication, what will happen? It will try to bring the service online, and whenever to try to bring the service online, it will try to take the ownership. So that time we can see the data corruption. So using the quorum information, the quorum will write the uh, cluster log, right? So that it will tell this is the active node, this is the passive node. So based on that, it will take the ownership. So that is the reason quorum is the main important. The quorum will maintain the all the cluster configurations. The quorum will maintain the all the cluster configurations using the storage disk, maintain the cluster log. It will record all the information, active and passive node. And if your active node is really down, then it will allocate the resource to the active node. Okay. Otherwise, what will happen if you lost the communication from the private network? Then one computer think like other computer is down, it will try to bring the resource online because the lost the communication. That scenario, they will try to take the ownership. But if you do like that, the disk will corrupted and we can see the other issues. So if you have the quorum, what it will do? It has the all the log information and it will maintain the active cluster SQL Server information, and based on that, it will stop the other service not to come online. If it is not service not coming online, it will take it won't take the ownership. That is the purpose of the quorum. So interview they may ask how many types quorums we have. So we discussed quorum, right? The quorums are 4 types. Those things I will explain later, but quorums are 4 types. In the always and easy, generally we can go for file share or node majority. While discussing about the always and easy, we can go for the quorum types. So and also we can go for the patching. The patching time we can discuss the how the failover will work and how the other things will work. So this is for the theoretical part for the clustering, but installing the clustering, 2 things involved. One is Windows cluster has to build and we need storage. After that, we need one like installation. In that installation, we require virtual name and as well as the IP address. So now the interview will ask in the clustering 2 things. How can you apply the patching on the cluster, and how many IP address we required, how the failover will happen, and what is the quorum, and one more thing. So the thing is like one more key topic called is alive, is alive, look alive. This is the background. The process will work for the this node available or not. Okay. Using this is alive, look alive, failure will happen because quorum is writing the information, right? How the quorum will work is using the this background checks. The quorum will maintain the active node information. So the is alive, look alive is means look alive every, yeah, look alive every 5 seconds trigger from the background, and it will check that particular computer the SQL servers up or not, and is alive every 60 seconds. It will activate and it will check the that particular computer the SQL server up or running, like SQL servers running or not. This node is available or not. Okay. Then based upon the this background checks failure initiate from the quorum. So here the failover go for automatically or else manual failover. The manual failover we can perform from the DB team or any one of them. But automatic failover will happen based upon the node availability or any other issues. Using the use alive and look alive, the automatically failover will happen. So the clustering is the entire server level high availability, that is maintaining the our hardware and server failures. If something goes wrong one computer. Other computer will take the ownership of the resource and the SQL server will come online. So that means suppose normal database availability. One node computer is crashed. Then what we are going to do? We need to build the one computer and we need to install the SQL server and we need to restore the databases, right? So if you go for the clustering is nothing but the join of the computers. That may be one or two or three or four or other. That is based upon the Windows cluster flavor. We can join together the computer nodes. One computer having issue, another computer is ready. It will take the ownership of the SQL server. But the thing is like to maintaining this environment, the cost is involved like more. Why? Because we need to maintain another computer, right? So for that we required RAM and CPU. The disk no need to pay. Why? Because only the disk will assign to the our active node. But coming to the CPU and RAM and we need to go for the uh, what I meant to say CPU RAM, right? I need to check for the SQL license. Okay, I think SQL license also it will take. Why? Because the binaries will install, but it is stopped. If it stopped running, license we need to pay. But let me double check and come back. Generally, I never faced the for license in the clustering, but I will give the confirmation. The drawback is like we need more cost to maintain the another computer. Then we are more what I meant to say drawbacks. Yeah. So if something goes wrong in the disk, that required again storage disk, right? So that is a drawback. But main advantage node availability. It's like a computer availability. If the computer's availability is there, our SQL server will move to the another computer. The service will up and running. So the availability we are giving within 3 minutes. Suppose this computer is crashed. What are the resources we have? That will move to another computer. Moving the resource, it will take 3 to 4 minutes and the SQL service will up and running. So that no need to wait for entire 24 hours are based upon the Windows team like activity, right? So no need to worry about the our node availability because the node is already available, the bind is already installed. It will take just one SIM. So once we fail over, the resource will move from here to here and the SQL service comes online. Then business will up and running. So that is the main advantage. And another main advantage is SQL server patching. So SQL server patching, if we go for standalone, we required 45 minutes downtime. But if we go for SQL Server clustering, here also required 45 minutes downtime. But we can avoid that 45 minutes using the advantage for the our Windows uh, server availability. So the patching availability, like patching applying in the one shot, we can apply standalone and as well as clustering like always energy so that we can explain the patching part in the our SQL clustering theoretical. But the thing is like we need to understand the like interview they may ask, okay, how many IP address we required to install the SQL clustering. Okay, how many IP address we required to install the SQL clustering. So let me go for simple setup 2 node cluster. This is the one computer. This is the one computer. We join together. Okay. We join. In this cluster. So this required one IP address. Okay. So as I mentioned previously, we need two network card set. One is for public, another one is private, right? So this is required one IP address. So here, here one IP address and the private, each computer having private NIC card and public NIC card. So then we required one private IP address, one public IP address. In another computer, we have one private IP address, one public IP address. And we are installing the SQL server, right? While installing the SQL server, what I mentioned, we need one virtual name IP address. That is for client access point, right? So for that, we required one IP address. For that, one IP. So here, one IP, one IP, one IP, one IP. So here we have a two node cluster joined together in the Windows cluster. For that, we need one Windows IP, Windows cluster IP, one private IP address for one computer, one more private address for another computer, one more computer public IP address, one SQL server installing. So here just we add the binaries here. So this setup we can call like a active passive. So in the active pass two node cluster, how many IP addresses we required? 1, 2, 3, 4, 5, 6. Okay. And we have a one more called EMS DST. So for that also we required one IP address. This is optional EMS DMS DMS DSA MS DTC MS DTC. So this one also we required one IP address. So here this is the two node cluster. In the two node cluster, we install SQL Server one computer and that SQL Server we added to the another computer. Okay. So this setup we can call like a active passive. Why? Because as I mentioned previously, uh, go for SQL Server services will running here. SQL Server will services running here. running here, and here the SQL service will stop. SQL server will stop. SQL server stopped. So here the one computer having the one what I meant to say here, uh, it's a one instance or the computer having the one SQL server running here, another one is stopped. Why? Because we added this setup you can call like a act to passive. So we have one more setup called act to active. Act to active means like each computer having the their dedicated instance. See here, VM1 having dedicated instance, it's running, but we added, but that is stopped. So one computer only having the one main instance. If you go for the one more setup called like we install the SQL server here, we added here. So this is the B, this is B dash. So here what will happen? SQL server running and agent service also running here, stopped, stopped. So in this scenario, what is each computer having one uh, having SQL service running. So that means each computer having dedicated instance running. So active passive means and another partner node, the SQL servers are stopped and only one node SQL servers are running. Other computer, the SQL server stopped. But here each computer having dedicated instances and it is running. That setup we can call like a active setup. Initially VM1 only uh, one instance running. We add only one SQL server here. That setup we call like a active passive. But here two VMs, each VM running SQL servers running. That setup we can call like a active. But the thing is like we have. Let me take a small example here only. Let me finish in another 5 minutes. Don't want to take the same setup. I'm not going to change anything. What I'm going to do, this is the SQL server A. I added, and what we did, it's already running here. What I did, we fail over to here. We fail over to here. Okay. What will happen? The both services will running in the one computer. Okay. Both service will running in the one computer. Both. So previously B is there, actively running on the VM2, what we did, we fail over to VM1. We fail over to VM1. VM2. So initially what we did, we have VM1 computer, VM2 computer, we install the A and we add to the here. Main SQL server install B and we add to here. So later some point of time, what we did, we fail over the B to VM1. We fail over B to, come on, here. Then what will happen? The SQL servers will running here. In a way, it's here already running. So then in scenario, what will happen? Here both will be stopped state. So this setup, what we can call active passive. Why? Because one computer, nothing is running. It's stopped. But here the SQL, here two instances running on the one computer. The other computer simply uh, like a high availability purpose. It's not uh, client connections are hitting. Why? Because once we fail over, the SQL server is up and running and client connection will connect to here. And other VM2, what are the binaries we have, that related service will be stopped. So this setup we can call like a active passive. So active passive means in the another computer, nothing SQL service are running. Okay. That setup we can call like a active passive. Active means at least one SQL service if it is running, that setup we can call like a active passive. Let me take one more example. Let me finish it. This is the computer. This is the computer. This time what I did, like I have suppose 836. Let me stop it. Okay. Maybe tomorrow. Tomorrow we can connect and I can finish this theoretical part and we'll go for one more key topics. Okay. Let me stop the recording here and we can more discuss about the active, passive and active. If you're not aware this concept, what will happen? The people are, by looking at the services, they starting the services. This was happen in my environment. Okay. So the people generally what they will think, if your SQL service is stopped, they will try to start it, right? So first of all, we need to check if it is cluster. Don't start it. Why? Because that is the behavior. One at a time, the service will be running on the one node, the another node, like a partner node, it will be stopped. So first of all, we need to check that particular services SQL server is a cluster or not. If it is cluster, don't start it. So the my like as per my experience, like the people what they're doing, they are not much aware of the clustering. By looking at the services, if they see stopped it, they're starting. If they start services, what will happen? The disks are like confused. Which one it has to own it? Then it will get a data corruption. So that is the reason we need to understand the active and active passive concepts. Okay. Uh, but anyway, in the future, it's no more, but it's up to based upon the requirement because it's a high availability. Okay. But we can get the clear picture when we go for the always energy setup. That time at least we can see the active node like a warners. That time we can see. Let me stop the recording. We can go discuss tomorrow other topics and by completing this session. Okay. Okay. Thank you. Let me stop it.